Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. Day 8, the Treetop Treehouse. The expedition comes across a peculiar patch of tall trees, all planted carefully in a grid. The elves explained that previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a tree house. First, determine whether there is enough tree cover to keep a tree house hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or a column. The elves have already launched a quadcopter to generate a map with the height of trees, your puzzle input. For instance, this example, so we have a 5x5 grid. Each of the tree represented as a single digit, whose value is the height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the other trees between it and the edge of the grid are shorter than it. Only consider trees in the same row or column, that is, only look up, down, left, right from a given tree. All the trees around the edge of the grid are visible, since they are already on the edge. There are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. All the trees around the edge of the grid are visible, since they are already on the edge. There are no trees to block the view. In this example, only leaves the interior 9 trees to consider. The top left 5 is visible from left and top. The top left 5 is visible from the top and left. Okay. It is invisible from the right or bottom since other trees are of height 5 are in the way. Yeah. The middle top 5 is visible from top and right. The top right is not visible from any direction, for it has been for it to be visible there would need to be trees of height 0 between it and the edge. Okay. The left middle 5 is visible only from the right. Okay. Yeah. The left middle 5, yeah, the center tree is not visible from any direction. Okay. For it to be visible, there would need to only be trees of the most height 2. The right middle 3 is visible from the right. Yeah. In the bottom row, the middle 5 is visible, but the 3 and 4 are not. Yeah. Exactly. Yes. With 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. Consider your map. How many trees are visible from the outside of the grid? Get your puzzle input. Yes. So all the edge ones are already visible as they are, because they are on the edge. So a total of 21 is visible in this arrangement. Okay, we need to figure out if something is visible in order to be counted. So we need some kind of function to check if visible. Then we need to figure out, we need to have a grid with all the numbers. So that's another problematic thing. So I think I will start here by just create a bunch of strings here. So rows. And this is just so I don't have to have a bunch of variables to figure out how large stuff is. So here I can take, I can create an int array of arrays, grid, and it should be equal to a new int. And here I need to specify how many rows I have. So that is the rows size. So I can say that the number of rows is equal to row size. And int number of columns is equal to rows and get 0 length. So now we have a number of rows and number of columns. So for each of these rows, we need to take the grid and add a new int array of number of columns size, and there we need to put in the actual values. So we will split the row up of each value, and then do the same for the row array. Column value column string, and then call value, and we can just go row grid I int j integer parse int integer parse int call string. So there we go. Now we have some kind of value in a grid. So if we do a system out here, what is going on? Yeah, of course, we need to have that. There we go. So if I check here, not on day 7, need to run day 8, of course. Day 8, run. So here we should have 5 by 5 grid. So we should have read all the numbers here. So let's check if this is the correct array. Yeah, it seems like we've read this array and have some kind of an idea of where we are. So that's good. So now we need to have a function. Public static Boolean visible. And then we need to figure out on the grid if X and Y is visible. We return true. It's always visible. So we go through X, column number columns, like that. Surround that with a Y coordinate. Count. We'll add visible grid X, Y, and if it's true, we will add one. If it's false, we'll not. So if we type out count here, we should get the full list of values. We have 25, but we know that there are 4 that are hidden at the moment. So that is what we need to figure out now. So f x minus 1. Let's see here. So now we need to count all the values in a certain direction and see if all values in that direction is smaller, right? Get the smallest value in any direction, right? Get public static smallest, and then we have the grid again, and X, Y, and direction. Like that. So if smallest grid X, Y in direction -1. Let's see here. What direction should we have? We should have final east, west, north, south, like that. east. If smallest in east direction is smaller than the current grid x yx, is larger than. Turn it false. Should we find the largest? Yeah, largest value. Like that. West, north, south. So if the largest value in any direction is larger than the current value, then it's not okay. So and here we have east, which means -1, where west means +1, north means -1, and south means +1. So those are given already. So if or k switch direction, so that's what we want to switch on. And then we have a case of east, west, north, south. So east, if x is larger than 0, then we run largest on the grid again. X -1, y, dear. If that value is larger than grid y x, then return val, else return that value. And here we want to just return that value, right? Is that correct? So if we have more to the east, then we have to fetch that value, and if it's larger, that value, then we will return that value. Else we will return the current value. And if it's less than 0, we will just return that value. Let's see, if it's less than 0, we can't return that value. So then we will return 0. That is correct. So if we do west, we do the same, but we say it must be less than grid 0 length. And then we can do plus instead and do the same calculation here. And if it's north, we'll do minus y. And then we check y. If y is larger than 0, we can do this. And last but not least, we check south. And here we will do y less than grid length, and we will do a plus. So what will this yield? Will it just crash? No, it will give us 6, which is not the correct value. So that's not good. And so this seems to be the correct way of doing it. So let's try it with the larger example here and see what we get. If it can run it. Then we got 1,809. So let's see if that is correct value. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So we had a couple of issues here. But mostly we just wanted to check in one direction. So we go through and check if everything is visible here. And the visible part is going for each of the different directions and see if anything is larger in that direction. So we find the largest value in any direction, and then we compare that with the current value. And if the largest in that direction is smaller than the current value, then this is visible. And what we do up here is pretty much check if we can go more in that direction. And we can do that if we are not outside of the loop. So here, for instance, we can't really check a x value that is smaller than 0. So we'll check that it's larger than -1. And if so, we can check that value there. Otherwise, we will just return -1 because then we are outside of the grid. And we get the largest value here and we check that that is larger than the current value that we are looking at. And if so, we will return that value. Otherwise, we will return this as the largest value. So that is the current solution for part 1. Let's look at part 2. Content with the most amount of tree cover available. The elves just need to know the best spot to build their tree house. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, and right from the tree. Stop if you reach an edge and at the first tree that is the same height or taller than the tree under construction, under consideration. If there is a right on the edge, at least one of its viewing distances will be 0. The elves don't care about distant trees taller than those found by the rule above. The proposed tree house has largest eaves to keep it dry. So it wouldn't be able to see higher than the tree house anyway. Okay. In this example above, consider the middle 5 in the second row. Okay. Looking up, its view is not blocked. It can see one tree of height 3. Looking left, its view is blocked immediately it can see only one tree of height 5, looking left, right next to it. Looking right, its view is not blocked, it can see 2 trees. Looking down, its view is blocked eventually, and it can see 2 trees, only one of height 3, and then the tree of height 5 that is blocks its view. A tree's centric score is found by multiplying together its viewing distance in each of the 4 directions. For this tree, it's 4, found by multiplying 1 times 1 times 2 times 2. However, you can do even better. Consider the tree of height 5 in the middle of the 4th row. Looking up, its view is blocked by 2 trees. It's blocked at 2 trees by another tree with a height of 5. Looking left, its view is not blocked. It can see 2 trees. Yes. Looking down, its view is not blocked. It can see 1 tree. And looking right, its view is blocked at 2 trees by a massive tree of height 9. This tree's scenic score is 8. This is an ideal spot for the treehouse. Consider each tree on your map. What is the highest scenic score possible for any tree? Okay. So, it's very similar to the score that we already had here. The only difference is that we want to figure out the largest value of visible trees. So let's go in here and say we do the same here, and then just say largest scenic. That's the largest scenic value. And then we have this function of new scenic get scenic value. That's the scenic value. And if the new scenic value is larger than the largest scenic value, we will set the largest scenic value to the new scenic value. And we'll do a largest scenic value and then print that out. So that is the result we will have here. We'll create this new scenic. We continue to do the east, west, north, south approach here. So we will just get the north value. Number seen of the grid here. So let's start with the east value. And then we need to have east should be -1, right? And then we will have the grid current value. So that's just x and y, like that. And then we do the same for all of these. And then we will just do east west, north, south, west, north, south, and we'll return this, which is east times west times north times south. So that's the problematic thing. And I wonder if that is okay that we exclude the edges. Let's do that now, because the edges will always get 0. And that's not a good value. So then we will take this long functionality here and then say number seen instead. Like that. And if so let's see here. We have a value and we want to go east. If this value is smaller or larger than the current value, then we can see further. Then we will take, this will return 1 plus number seen. With that direction. So I wonder if it's just the same for all of these, but we just change up which direction they should go. Else return 0, I guess, for all of these. So this one we want to do minus. And the last south will be like that. And we do plus there. And now we just need to go back and see that we get the right value here. So what score would that be? Array bound out of bounds. If x I think we need to have another function here. If it's larger, then it can do this, else it will return 1. So we'll check if it's larger, else return 1. Because if it's not larger, we still see a tree. It's just that we don't look further. So that's my going hypothesis here. So what do we get then? Then we get 8. So let's check what we did here. Remove that one. So what we did here is that we first have a list here where we go through and find the largest scenic value. We will get the scenic value for each position. If that scenic value is larger than the largest, we will add it to the largest. Then the scenic value is if we see in every direction and we then multiply those. And when we look in different directions, we put in the current value as well. And if we just look at the east direction, so first off we want to see, are we on the edge here? So we can't really look further to the east. And if we are on the edge, then of course there is no trees. So we return 0. If we are not on the edge, we will see if we want to look further. Can we look even further? And in that case, this value that we have needs to be larger than the value that we are seeing at the moment. Then we can look further. Else we see one tree. But if we can look further, we see that one tree plus whatever is further away. So we will run this functionality again to see further with number of seen. So we do a lot of recursion here. So let's switch it up and see if we get the right value for the larger value as well. So the best place is at 144, if that is correct. So let's put that in. No, it's not the right answer. It's too low. Make sure you have the full input data. We also have general tips on the about page. So too low. So this seems to be the solution. Of course, when we're looking in different directions, the current value doesn't change just because we are moving in that direction. That would be crazy. We can still, if we are at the top of a tree that has a height of 5, we are still on that height 5 when we're looking away, not height 1 that the tree between to the left of us could have, for instance. So let's put in that answer. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So that was the solution. It took a long time for me to figure this one out. And it was such a simple mistake. And that's usually it. When you have something that is very complex, you need to double check all your values. And this was such a simple assumption that you should just change the value up here, but you shouldn't, because you are looking further on the current tree that you are your tree house is built upon. So we solved it today as well. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions, or you want to show me your solution, then leave that down in the comment section down below. I love to see other solutions so I can understand more and learn more from you. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.